Modern web applications are incredibly complex, deeply nested structural blueprints that constantly shift, reassemble, and change their shape in real time. When writing automated tests for these interfaces, engineers usually rely on static identifiers, like fixed IDs, names, or classes to target elements. However, in today's front-end frameworks, these surface-level tags are often missing or are dynamically generated on every single page load. This creates a critical point of failure for an automated testing script. It attempts to interact with a target element, but without a static identifier to latch onto, it throws an error and halts the entire sequence. If a script cannot reliably identify and target these elusive web elements, the automated testing pipeline ceases to be a reliable tool. Continuous testing requires a targeting method that functions despite a changing interface. Every web page is built on a structural map known as the Document Object Model, or DOM tree. This is the explicit hierarchy of nodes that dictates how a page is assembled. When surface identifiers fail, automation frameworks like Selenium turn to the XML path language, better known as XPath, to traverse this map. XPath ignores the absence of surface-level tags. Instead, it locates elements based on their physical and logical relationships within the DOM hierarchy. To build resilient automation scripts, engineers must move beyond basic surface locators and learn to query the underlying structure directly. The most literal way to use XPath is to write an absolute path. This rigid, step-by-step traversal starts at the root HTML node and maps every single branch down to the target. This schematic illustrates absolute XPath. A solid trace line steps from the root HTML tag through specific divs, landing on the input field. But if a developer inserts one new wrapper div, the physical route changes, snapping the line. Because the path is hard-coded to the second div, it malpoints at the wrong node. The next time the test suite runs, it will immediately throw an element not found exception. Mapping an exact route ensures minor updates break the test. Absolute XPath is an architectural liability. To solve this structural fragility, engineers must completely decouple the target element from the rigid framework surrounding it. This animated schematic shows relative XPath. By starting with a double slash, we instruct the script to act like a scanner, searching the document regardless of depth. Instead of following a specific map, the scanner drops a direct anchor onto the target node, relying on attributes rather than coordinates. Now watch as the surrounding framework shifts. Wrapper divs can be added or removed, but the script maintains its direct lock on the target node. Bypassing the root hierarchy and searching directly is the primary step towards scripts that survive changes. Let's break down the syntax. The double slash triggers a relative search anywhere in the DOM. The input tag narrows the search to that element. The attribute condition isolates the exact ID username. For precision, stack multiple conditions using the AND operator. Mastering this syntax allows testers to build specific queries that rely on explicit logic, rather than fragile physical location. But there is still a challenge when dealing with dynamic data. Modern front-end frameworks automatically append random strings of numbers to element IDs on every single page load. If an element's ID is user 1234 today and user 8923 tomorrow, strict attribute matching fails because the ID string is constantly mutating. To handle this, XPath uses dynamic functions. The starts with snippet targets just the predictable user substring, ignoring mutating numbers. Alternatively, the text function locates an element by querying its visible text instead of hidden code attributes. Using partial strings and visible text allows locators to survive aggressive dynamic framework generations. The goal of any automation pipeline is to ensure testing scripts survive continuous, rapid software development and deployment cycles. This split-screen comparison illustrates the two methodologies in action. On the left, the rigid absolute path breaks as soon as a node shifts. On the right, the relative path maintains its lock on the target. In professional development environments, absolute XPath is treated as a structural anti-pattern because of this inherent fragility. Robust element location relies on three pillars: using relative syntax to decouple from the root hierarchy, stacking multiple attribute constraints for exact precision, and implementing dynamic string matching for mutating IDs. By defaulting to relative XPath, QA engineers move away from high-maintenance manual intervention and toward a resilient, scalable engineering practice.